Good morning.
Hello.
You always change. Back it up. Do it again. 3, 2, 1.
Hello.
Hello.
Welcome. Hi. This is the last class. And by Friday at 6 p.m., done with 1070, hopefully. Yay. So, awesome. I'm delighted.
I mean, yay.
Yay.
We're yay for you.
We're kind
kinda
of
sad.
devastated.
Yeah, it makes these sessions kind of more awkward because no one else is here.
Yeah, we still come and teach.
Yep.
And this is the last time that we're teaching 1070 for at least the next 2 years.
At least, and so that means 3 1070 cycles, right?
That's
so
right.
not next term,
Yeah.
not next fall,
Yeah.
not next winter.
Yeah, and we may never teach it again.
We may never.
They may make us teach like...
I want to do histology. You see a thing? Can we cut it thin? Okay. Can we cut it thinner?
Amazing. Okay.
I kid. Histology is very important.
Yeah, so feel free to check in with us because we may just need a check-in.
Yeah, come and take 2700 next term.
We're gonna.
I'll be like, it's right over there.
It's right
like
next
it's
door.
right on the other side of that wall.
Yeah, his office is not nearly as nice as mine.
Awesome. My mom teaches histology. That's so cool.
Oh, that's so good. Okay, so we'll get your mom to actually teach histology.
I used histology to estimate the age structure of toads once because I had to slice their bones and count their age rings.
Amazing.
Because toads have age rings like trees.
How many age rings do we have?
I feel like I've got 17 in the last 3 years.
Yeah, it's been really hard.
No, actually, we would have no age rings because age rings requires you to have a resting phase.
No resting phase.
There's been no resting.
There's
it's
just
like
a band.
one long year. That's why it is March 996, 2020.
84 years. Yeah, it's been really... Yeah.
What other courses do we teach?
So all of mine are getting cut and decimated because Jacob's is not... conventional. Yeah, we'll see. Yeah.
So we can tell you what courses we have taught in the past because we're generally given our teaching assignments kind of 2 years in advance, which seems like a luxury, which it's pretty luxurious to be able to. It's kind of necessary to prepare.
Yep.
But because we'll both be on sabbatical next year, we don't actually know officially past the fact that I am teaching the invert morphology and evolution next term.
Yeah. And then it'll be at least 1.5 years before we teach again.
Yeah. I mean, who knows? We might have another invertebrate phylum by then.
There could be a whole different university by then.
Yeah. Wait a second. We might have flipped everything back to memorization. No, that won't happen.
Yeah. So my Arctic biodiversity course in Iqaluit got canceled. And Icon that I teach as well also got canceled because they are awesome and not part of the core program because they are awesome. And so there you go. So we will see what we are all teaching.
We're having some growing pains.
Yeah.
This institution of yours.
Yeah.
So pay attention to that because there's some things that you might have come expecting that might be hard to find. So we both teach field courses.
Yeah. And the first year seminars got canceled.
Yeah. Make a noise about that. That's kind of garbagey.
Yeah. So if you're in a first year seminar in the winter, it will still run. But then it's over. And if you are in a first year seminar, I would strongly encourage you to write to the provost.
Yeah, the UNIV courses. That's right.
That's right. The provost's email address we will pop in the chat, please. It doesn't have to be like a super long email, but just a little, why you've enjoyed the UNIV courses, UNIV 1200. I used to teach them, and then they stopped paying people to teach them. So that was the end of that. And anyway, it like all the good things. So like the first year seminars, my Icon course, which used to be a UNIV course, and my field course, and all of these like good field courses are getting canceled because of budget cuts, right? So this is what's happening. So please feel free to express concern. It doesn't have to be rage if you're not outraged. But just, it would be amazing if we could save them. What else? Cool.
So what other courses do we teach? I have taught
I used to teach humans in the natural world, which was so fun.
Mm-hmm.
I just interrupted you.
What else?
I used to teach the ornithology course. I used to teach your course.
Mm-hmm.
I used to teach in management and business consulting, ideation, problem solving, innovation, creativity, stuff like that.
Mm-hmm.
I was supposed to teach in the arts and science program, but that got canceled. I was going to teach nature-inspired solutions.
Mm-hmm.
I was so looking forward to that, and it got canceled. Everything gets canceled. And it's not because, like, I'm bad at my job. It's just that they were good courses.
You're in a dark place,
I'm
Dr.
in a
J.
dark place.
So I have taught the Algonquin Field
yeah.
course with the Field Ecology, which is a great course, whoever's teaching it. I have taught the Arctic Ecology Field course, which is in Churchill, Manitoba, so it's technically a subarctic Field Ecology course, which is also a great course. I have taught the fourth year Ecological Methods course, which is kind of a course that's run in the fall term, but is like a field course in that you work as a team and collect data and analyze data here on campus. I have designed a second year field course that is local, that we'll see if they ever run again. And I have designed so look forward to maybe ask about that kind of thing, because it was designed to be more equitable and accessible and takeable. And I've designed a tropical ecology course, which I am just waiting for somebody to express interest in so that we can do it, because we could do it like tomorrow.
Oh, and I taught a virtual field course.
Yes, you did.
That got canceled. There's a pattern here. And it's breaking my heart.
Is it their plan to relaunch the courses after it's canceled for a few years?
It's possible.
Maybe, but they haven't expressed that.
No.
And that's a concern.
Yeah, probably not.
Do we have an extra lecture on Friday to make up for the one we missed? No, we do not, because the one you missed was a holiday, and we are firmly under the impression that holidays are holidays. And you don't have to make them up. No. It's like they're a holiday.
They're a holiday. But we have extended the topic test
into
Friday. So topic test starts at 9 on Thursday and Friday. Pick a time that works for you. You can't come back to do it. So once you log in, you've got 3 hours, which should be more than enough time to just relax and take it. And then please, we are closing it at 6 p.m., which means if you want the 3 hours, you have to log in by 3 o'clock in the afternoon. And again, you shouldn't need the 3 hours, but it's there for you if you want it.
So, there is no lecture on Friday. Don't we have Monday classes on Friday? No. I hope a couple of you noting that you chose Guelph over other schools because of field course options.
Yep.
And that's important. And that's a thing you can keep telling the higher ups, including that provost email that I put in the chat.
Yep.
That the requiring those, there's fields, you have streams and majors in if you're in IB that require you to take those kinds of experiential learning courses, and so we can't really take them away from you as an opportunity without and still require them.
And the other thing is that I've been told that because there's no money for my field course to Iqaluit, but if I can find money to do it, then I can offer it. So basically that would mean paying your way up there and food. But if you can do that, getting a scholarship, or your parents have deep pockets, or I can get some philanthropical money. I'm going to go and talk to alumni about raising some money. So if I can do this, I will send an announcement to all of you that it will be offered because it's awesome. But also it's a second year field course, which was like super important to me that we have field courses in second year, not just fourth year. So if we are running it, I will send you an email. It'll still probably run about $2,500, if not more. So I just can't, we lost the funding for it. So I'll keep you posted though.
Is the test multiple choice, true, false, or short answer as well?
It's the usual stuff. I think there's some short answer this time compared to the second topic test. It's probably more similar to the first one.
Yeah. So some of those courses are still running. So you kind of need to check it term by term.
Yeah.
For Algonquin, I believe, has been confirmed that it will run. I don't think Churchill will.
No, Churchill isn't running.
All the Arctic. St. Andrews, I think, is running.
Probably.
The marine and freshwater one, I think, is running.
Probably.
Yeah.
Okay. Keep in touch though.
And you also, because you're at Guelph, we are a member of the Ontario University's program in field biology. So there are field courses you can take that are offered by other institutions while you're here, and you get a Guelph credit.
Mm-hmm.
So, but
please write to me.
Come out of your dark place. Here,
I'm over here. Follow me. Walk towards the light.
To the light.
Yes.
I'm gonna miss you all. Okay, here we go. Ready? Good.
Are we?
Arctic field course. Woo! Yeah. There are some good opportunities. Okay.
If we do worse on topic test 3 than we did on the other 2, it will be disregarded.
Yes.
I changed your question to a statement. Yes.
Yes. And I think students tend to do a little bit better on this one than they do on the second one. No, generally, that's like the general pattern. Yeah. But they also tend to do worse on topic test 2 than they do on topic test 1. And you guys didn't do that. You got about the same. So, like, you're a bit of an anomaly to me. Okay. Are you ready?
They're out there going like, oh my God, we're ready.
We're ready for it to end.
15 minutes in.
Okay. They're still coming in though.
Yeah, I know.
Okay.
That's because of the traffic. Now, I want you to join me in something.
What?
I want you to green mile it before we start.
Okay.
3,
Ready?
2, 1. I'll add those things in post.
Okay. Awesome. Thank you. I feel much better.
Here we go.
Okay, here we go. But the cardinal is gorgeous. And so is this rose. Oh, and these flowers.
All of the things are.
Oh, you love it. Love it. We will miss you too. Okay.
Hey, I am pretty anomalous too.
Okay, here we go. So we're going to wrap things up, basically. We're going to wrap up the polar bear story that will hopefully continue to blow your mind. Previously on 1070 and the polar bear story, we talked about...
You have to say that in a Homeland voice, though.
Oh, did I?
It was good.
It was good? No?
Previously on Homeland. Because I just asked you to come back to the light, and I'm like, no, you got to go back to the dark.
I got canceled. Okay, so just to kind of recap on what we were talking about with the polar bears is that there is I don't even think we actually said it. There is extremely strong evidence. In fact, it's kind of a thing. Like, we're pretty damn sure that there was this intensive hybridization event that happened with polar bears.
We said it.
We said it?
Yep.
Okay, so polar bears evolved probably from the population in the ABC Islands, the brown bears, or whatever the common ancestor was around the area of the brown bears, or around the area of the ABC Islands, evolved into polar bears. There's this whole fantastic theory about gray bears that no one knows about. That's pretty fun. And sort of like the transition bear into polar bears. And then polar bears at some point hybridized again with brown bears to create what we now understand is the polar bear.
So remember, that was the phylogeny, the overlaid. So we had a phylogeny running from top to bottom, and the oldest lineage branching off was the black bear, or the first lineage branching off species was the black bear. And then polar bears and brown bears share a common ancestor, branched off, were doing their own thing, and then that polar bear lineage, the mitochondrially, kind of stops, and that's our hypothesized hybridization event in the ABC involving the brown bears from the ABC Islands about 160,000 years ago.
So what do we take from that? What we take from that in the context of trying to understand what might happen with the climate crisis, the key bit of information, there's all the information that's not relevant, and then some information that's relevant. That the information that's relevant is that these species are potentially still interbreedable, right? Okay. And now let's take a back up.
So why might that be, particularly in the Arctic? And it's because a lot of these places are recently colonized in evolutionary time.
Good.
So these species are not old. Even the older species, they're not that old.
Yeah. Right, and it says even here, extremely rapid evolution. So this is a very relatively recent speciation event that happened between these two species, and there are some implications. So remember that big long scary table of like all of the things that were the differences between the brown bears and the polar bears? We can start to take a look at those things. And what was really interesting was the ones that you identified as being really important. They are important. There's no question about that. But there were a few things that we would like to add to that list that are even sort of potentially more immediately important.
Yeah.
Is that fair?
Yeah.
Okay, cool. One of them has to do with the cranial morphology of their faces, of their heads. Okay. And why? Because they are really adapted to the types of foods that they evolved to eat. The thing about, and so we ended off with that video of the hunting of the seal. And so when we think about a seal from a polar bear's perspective, a seal is a big bag of fat. And in a good year with lots of food, a polar bear will only eat the fat and will leave a lot of the rest of the carcass. And then, of course, scavengers come, right? These ivory gulls or foxes or whatever come and they eat it. And it's all kind of, kumbaya, circle of life. But lately, though, that's been changing because of the availability of fat has been decreasing. But basically, the skull of a polar bear is really just a very effective latching on mechanism.
Pop.
So a really good clamp, okay, followed by an excellent straw, right? So that's the face of a polar bear.
They're more of a tardigrade.
So not a lot of chewing muscles and not a lot of teeth, like chewing strong teeth.
They don't have a strong jaw.
They don't have a strong jaw.
That's why the polar bear wasn't in the Revenant.
They have a weak jaw.
Yeah.
Right?
The Revenant had a brown bear.
Yeah. And this kind of sounds counterintuitive, right? That, this uber predator would have this very weak morphology in its cranium, but it's consistent with what we see in the evolution of herbivores and carnivores, like across the board, right? When we think about species that are herbivores, think about horses and cows that have these huge teeth for grinding. They have these huge muscles in their cheeks, right?
Very strong jaw. That's
very strong.
That's why Westerns are popular, because horses have very strong jaws.
Very strong lines.
Yeah, they're very good.
Okay. Anyway, whereas carnivores are really, and especially polar bears, are fat-sucking straws. Okay, so this has consequences when we're talking about changing diet in the context of climate crisis.
And it also gives us a way to look for evidence of the climate crisis upon these species.
That's right.
So this is a neat study from not that long ago, but it is looking at where it's comparing kind of the cranium, the skulls of the brown bear on the right hand side and the polar bear on the left hand side, and how strong they are, where they stress and where they break. And so in this case, kind of the red is not stronger, red is weaker. So those are like stress points. And so you can see that brown bear, that cool blue and green measurement there of the brown bear. That's a strong, grindy, durable generalist's skull. This is a skull it could, if it needed to slurp, it probably could, but it's also going to be good at like eating
Berries.
mounds of eating mounds of dirt to eat ants, which is a real strategy that brown bears have. Polar bears don't want to eat ants because it involves too much soil.
That's right.
Now, one of the cool things about this recent study is this undergraduate in the background listening. I think they're listening to to some hot podcasts or tunes. What they're doing, part of the reason or part of the work, they did part of the work that contributed to that last kind of beautiful screen. And they did it by putting essentially Play-Doh on molds and on different skulls and different mandibles that already existed in collections, which is really cool. So it's essentially polar bear dentistry that they get to do. And we're not going to show it to you here, but please, when you get this slide later on, take a look. This is a click on this image and it'll take you to a video. And also as an aside, when we click, don't click on it or we'll go to the video.
If I could do it again, I think forensic dentistry would have been like a thing that I would have enjoyed.
Forensic ursine dentistry?
Yeah.
Bear dentistry
No,
specifically?
just forensic dent. I think it's cool.
Yeah, it is kind of amazing.
It's amazing.
Yeah.
Okay.
Now, this is kind of the output of one of these things. And so think about, because this research involved museum collections, it involved polar bear mandibles that had been collected, shot or killed or collected by museums over a long period of time that included present day, when we think there's a whole bunch of this climate crisis driven confusion and change in the historically available food sources. So what we have here, don't worry about what the labels are. Think of them essentially as we've got tough foods. As you go from the axes up on the Y, it gets into tougher things. And on the x-axis, it gets harder.
Yeah.
So as you're out in this space over here, that's probably not great. That's like you're eating, I don't know, you're a caribou scraping lichen off of rock. And down into close to 0 and 0, you're into like sucking on a nice fatty seal tube. And that is where we find most of the polar bear skulls. They do some tough things, but generally not hard things. Here, in the 21st century collections, we see some skulls that give evidence of existing in the ancestral kind of space, food space, but much more. We see this sudden kind of jolt of evidence of their food becoming harder, way harder, much harder than they've had to deal with ancestrally, including things like bones and garbage, scavenging, which is really indicative of stress. This is a non-traditional, stressful kind of a lifestyle.
Amazing. So let's combine then what we understand about their cranial morphology with what's happening with the sea ice. Remember, like from the very first day that we started with physiology, we showed you some sea ice data. We've connected that to the fact that sea ice is kind of a critical space for, basically, polar bear dining. They can't hunt seals that are just swimming around in the water. They're not fast enough. So they need to be able to sort of jump out of the water and grab them. But in the context of this declining sea ice, there's going to be a reduction in the availability of hunting opportunities. So we have decreased feeding period because that feeding period is going to get shorter on both the shoulder seasons of spring and fall. It's going to increase the fasting period, right? Making the summers even longer for the polar bears. And of course, even now we're seeing the reduction in the number of young that females are having. So, an average would have been in the high 2s, right? With up to 3 cubs. Now we're talking about 1, maybe 2 cubs that females are able to successfully rear. And so overall, we will see these population declines as a result of what's going on. And the question is, though, is the diet and the morphology able to support a change in diet and an adaptation over time? Or is the brown bear, who's already highly successful at maintaining an omnivorous diet, going to be able to outcompete? And so there are other, this is kind of the connection between body condition and reproductive success. So body condition is there are all sorts of delightful arguments about, how do you calculate body condition? And this is what I did for my PhD with fatty acids. So I have particular opinions about this. But oftentimes what you do for a body condition index, like a fast and sort of dirty estimate, would be to estimate the total mass of an animal and then to estimate its total fat mass. And then subtract basically figure out the sort of freshwater mass and the fat mass of the two, and then use the fat mass as your body condition index, or divide it by total mass. And then there's like all sorts of problems associated with doing that and whatever. So it's a delightful argument because sometimes you end up putting the same thing on both axes and whatever. Kind of fun. But generally, so body condition is just really overall physical health, right? But not just like, not the way that we think about it as humans, but with respect to their ability to survive and thrive, right? And what we're seeing is this overall decline in body condition of polar bears over the last, 40 years or so. And then we can start to ask whether or not hybridization events are likely. If these things do share a range border, it's very likely that that border will become even fuzzier as grizzly bears start to explore further into the territory of polar bears as a result of warming. And indeed, we do know that there are Pizzly and Growler bears, these hybrids, contemporary hybrids, that do produce viable offspring in the same way that they seem to have a while back with the first hybridization event. And so here is, and this is baited, so you can see this is a bucket of frozen food that was used to get the attention of this growler bear.
You can also see a lot of trees in the background.
Yeah. But anyway, so this is a hybrid between a grizzly and a polar bear. And in this particular case, the mitochondria would come from the polar bear and not the grizzly. And so it's kind of cool. It could go in the other direction, which is neat. So study questions, implications. These are things that you can think about. Are polar bears phylogenetically within brown bears, right? Obviously the answer to all of these is it depends, right? So you want to write down kind of what it depends on. Did polar bears evolve quickly and recently from brown bears? And you can take a look at the abstract that we've shared with you that kind of goes through some of that. And how will polar bears and brown bears interact when the ranges start to overlap? And so hopefully you can use this as a bit of a checklist for what we've talked about with respect to polar bears.
Mm-hmm.
Here is a question that you can use to guide some of your studying with respect to the mammoth and the ice fish. So we won't go through that right now, but it's just there for you to work through.
It is a gift for you.
It is a gift for you because we want to just check in a little bit on regional heterotherms, and we talked about that very briefly. Remember, we broke it down. We talked about regional, that is discrete areas, hetero meaning more than one, therms meaning temperature. So discrete areas in your body that are different temperatures. And we wanted to just introduce the mechanism by which that can happen, as well as talk about the adaptation, because I think it's pretty cool. So what we see, so oftentimes people have asked me, why don't penguin feet freeze, right? So penguin feet are on the ice, always in contact with ice, and they're walking along and they can move them and they're not frozen. And so the obvious question is, why don't they freeze? But actually, it's kind of an interesting question, because the answer is they almost do. The sort of extended question might be, why don't penguins freeze? And the answer to that is something called the countercurrent heat exchange system that creates the observation of regional heterothermy. So basically, the feet of the penguin are very, very close to frozen. And as we go up the leg, the temperature gets warmer and warmer until we get to the core here, okay? And the other thing is that we all think that penguins have really short legs. They don't. They have really long skirts. So they're kind of like wearing a pencil skirt down to their knees, which is here. But the rest of their leg is actually like way up in their body. And their core, like their body fat basically is just droopy, like all the way down to like the bare minimum that you need in order to be able to walk, which is why they walk funny.
Yeah, it's like the muffin top times 10 to the 6.
There we go. It's the evolved muffin top. It is.
Yeah.
It is awesome.
It's the evolutionary advantage of a muffin top. Just keep growing it.
Just keep growing it. It'll keep your thighs. So basically, this like body extending down keeps the thighs really warm, and the thigh muscles are really powerful. You really need them for endurance exercise. And so, why would you have them exposed to like Antarctica when you can wrap them in fat and feathers? And so that's a penguin. And they have this countercurrent heat exchange system. So basically what happens is with the, again, form and function, right? The close proximity of the arteries to the veins means that you have warm arterial blood coming down, and there's like very, very little in terms of machinery inside the foot of a penguin. Like it's just a bunch of tendons. There's not like a lot going on with respect to musculature or circulation.
And a fax machine. They're an old species, so they have this like old technology.
Okay, so there's like just the bare bones, right? Of what's
Good.
that? Not bad, eh? So okay, just the bare bones in the foot. We do have some need to bring in some oxygen and some, nutrition and blah blah blah. So we have these arteries that are coming down, and they're warm from the nice warm fatty feather pencil skirt, and then they go down. But the veins that are cold, right, from touching the ice, are wrapped around the arteries. So what happens is the arterial blood, as it's descending, heats up the blood in the vein, so that by the time it gets into the body, the vein blood is warm enough and doesn't cool the core nearly as much as it would if it was just going straight into the core. Okay? You end up with this regional heterothermy that looks, here, we'll take a look at a gull leg now. See, it's like super like scaly and like really, really minimal in terms of exposure of tissues, right? Body tissues. And we start, with a temperature of 0 to 5 degrees Celsius. And then by the time we get up into the core, we're almost at body temperature, which reduces the amount of heat loss. So it's a really cool system. Counter current heat exchange system. There you go. And the heat is going from the artery into the vein. So by the time the artery gets down here, it's cold, right? It offloads all of the stuff that it needs to offload and then comes back and gets heated up by the arterial blood that's going down.
So what's critical here? Throw it in the chat. What would you be risking if the venous flow didn't heat up? If you're a bird,
what would happen?
A dinosaur, what would happen?
If you didn't have this.
Smith stares at the chat. Cold blood. Yes. Yeah, and cold blood in your core.
And loss of the extremity.
Yeah. So if you don't, so and then potentially loss of homeostasis, right? So this is kind of a critical thing that this is a real adaptation towards having these appendages that are away from the core that let them retain function, but also retain the comparatively stable temperature that's necessary to be an endotherm in a polar region.
Yep.
Or in an extremely cold environment. Not even necessarily polar, like in our environment. Now, do we have something like this? Yes, no question. Who cares, right? But do you?
Do I?
Yeah.
No way.
No.
My hands get really cold.
Yeah, we don't.
I feel it.
But what happens then? What are we doing? What's our strategy towards? We have similar kind of needs in that we have extremities that will go through cycles of heat and pause that. Go back. You've got to mention this. Sorry.
Don't knit sweaters for oil. for cold penguins. They are not cold. No, this was a campaign that was done a while back, and they're freaking adorable. So of course, knit sweaters for penguins.
If it's raising money,
it's raising money.
Yeah.
But penguins don't need sweaters.
Oh my God! I'm just noticing the long, like the middle distance running penguin on the bottom with those long legs.
Oh yeah, look at the legs. That's awesome.
Yeah, that's awesome.
Okay. You talk.
Yeah. So what is our strategy? So this is a picture of, and you've experienced this. Like you've experienced it if you've shoveled snow in the wintertime here. If we just talk about like the banana belt of southern or southwestern Ontario. This is me in a kayak in freshwater. The air temperature is -20. The water temperature is clearly above zero, but it's very cold. And I was very cold. So how do we do these things? If you're shoveling or if we're kayaking in the wintertime, how do you do these things? Because we don't have that countercurrent flow. What we can do is change the constriction or the dilation of the arterial and the venous flow so that we can do, this is called, you're looking at a plot that's called,
thought you were a whale.
Yeah. I guess thank you, because that's beautiful. So cold-induced vasodilation. That's essentially what you've experienced when you go outside to shovel. The first 10 minutes that you shovel, so let's look at that x-axis here. Your hands get freaking cold.
And that's usually when I come inside.
Yeah, exactly. But, or if you're out here, you're freaking cold. If you stay there, so that what you're doing there is your body's going, whoa, 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 whoa. Maintain the importance of the core. Maybe we're going to have to sacrifice the fingers. Let's see how we do here. Up to 10 minutes. Then at 10 minutes, you're going to go boosh. And there's going to be this vasodilation where core blood is sent out to the extremities. And you're going to get warm. And it's going to feel amazing. And then that process is going to cycle. And it's going to happen again and again and again and again. It's not infinite. This is not a strategy that kind of prevents hypothermia. Hypothermia is way out here on the x-axis where you just the core is diluted. See, the peaks of these are kind of going down through time. But this strategy can raise the temperature of your extremities like by 10 degrees Celsius.
To help get you out of a situation.
Yeah, and to help maintain you in a situation so that you can keep working. So one of this particular graph was taken by physiologists who were studying tuna fishers, where they're working on the decks of ships in very cold conditions, like horrible conditions. You've seen some of those like reality shows. I don't know what they're called, but they're on
Dangerous Jobs.
Yeah, like just crazy jobs, and you're cold and wet the whole time. And they have a really pronounced kind of period, probably better than we would, those of us who get to work inside a lot.
And I've experienced the sort of the really low temperature in an accident that happened, where, you know, after 25 seconds of being in in Antarctic water, I fell. Well, anyway, my boat got tipped over on top of me. I had 25 seconds where I was able to control my muscles. And after that point, I lost total ability to move. It was really intense. And I didn't want to wait 10 minutes. I was in the water for 8 minutes. I didn't want to wait 10 minutes to see if I would get that fuzzy warm feeling. Yeah. But so it can be a real serious thing, right? If you choose to go in the water, then clearly there's like, you know, some psychological control that you can have over your body. But if you don't choose, my like advice is to do as much of the moving that you need to do as possible right away. Don't wait, right? Because your body is going to start to shut down in order to preserve core temperature, not just like, you know, your muscles, but like your brain and your heart and your kidneys. And so it's going to really start to protect those in an emergency situation. So move immediately to where you need to be that's safer. If you can. Yeah,
but this falls into line with you've got this period of time, and so there's a couple of kind of nuances, right? There's are you choosing to be there? If you're choosing to be there, you have some kind of I have a place to go after this. There's also then the difference in the water temperature, which is small but significant. That this is freshwater in temperate Canada. So in January, February, it's still, if it's
2 or 3,
not frozen, it's 1, 2, 3 degrees Celsius. maybe as high as 3, whereas the saltwater in Antarctica was
Yeah, minus 1.8.
yeah.
Yeah.
So that's a difference.
Yeah. Yeah. All of these things matter.
But I give this to you at the last day of November. We give this to you so that when you're next shoveling, you can do it.
You can do it.
You can do it. You can do it. You can do it. You can do it.
Just suck it up for 10 minutes.
What do you do when you're in a car sinking in really cold water?
Yeah, so the first thing that you do in a car is open the windows.
Yeah.
Don't worry about anything else other than getting those windows open, because once you get down to a certain pressure, you're not going to be able to break those windows. The pressure of the water is going to be too much. So first thing you do is open the windows.
I'll mime something that probably your cars don't have.
That's right. Yeah. And I took all of these like really fantastic safety courses for like air rescue, water rescue, all of these things, and you learn some like really valuable shit. So like, yeah, take these courses. But yeah, open the windows. Okay. Then worry about your seatbelt and a few other things. Windows first. Okay. So penguins, because yay. We talked a little bit before about population and organism and molecular sort of different biological levels of organization and adaptations to the cold. And we did it in the context of the polar bear. And so now I just want to show you what that might look like from the penguin's perspective, because we do go to population level adaptations to the cold in a way that we don't with polar bears. And we talked about why that before. So we have a population of of penguins. And we can talk about things like huddling to keep warm. And then we look at the organism level, and we look at this beautiful emperor penguin. And we can see that it is very round even for a penguin. It is particularly round. It is also the largest extant penguin species, but can you believe it? There were bigger penguins once, like 2 meters high.
With their giant long drumsticks.
Yes.
Covered in their pencil skirt of fat.
There we go. Look at this pencil skirt. It's so good. Anyway, their legs go all the way up into here. They have long legs. Anyway.
As demonstrated in the drawing on the bottom left. That's wonderful.
Yeah. Okay. And so they have very short flippers, right? That are pretty stubby. So reduced size of appendages. Their body is covered in fat. They are rounder and bigger than even some of the other penguin species. Their bill is also reduced in size compared to the king penguins, who have much longer bills. So emperor penguins are endemic to Antarctica, and they are particularly well suited. There are only 2 endemic species to Antarctica, by the way. The other one is a teeny tiny one, so totally breaks the rules. But for its, again, like evolutionary constrictions, it is particularly fat. And kind of follows along the same kind of patterns that we see. Then we can go to the organ system level and talk about adaptations to the cold with respect to things like the countercurrent heat exchange system. So we can see all of these different levels with these different adaptations, some of which are chronic, some like or acute, like huddling. Some of them are evolutionary, like just being a big ball of fat. And if that fat would change over time, then that might be chronic as well. So how it all kind of ties into all of those scales that we've been talking about from the beginning. And then what we could do is we could put these on the chart like we did for the polar bears, and really start to understand and question, right? These aren't like the answers. These are just things that we put there for discussion about, maybe it would be more chronic. It's all evolutionary to me because these are adaptations, and so they have evolved. But some of them change their states or their physiology over time, right? So you can take a look at that if it's helpful. But we're going to kind of wrap things up in the next few minutes.
Can I throw in one thing before we begin to wrap up? There was lots of questions about submerging vehicle. Wasn't I supposed to do this? Wasn't I supposed to do that? Yeah. Do you remember Dr. Popsicle from this space several weeks ago, where the researcher at the University of Manitoba who submerged tiny Rick Mercer into the cold to study his, and after kind of inserting something through his nose into his heart. His expertise and his is about submersion, and his website has a whole bunch of things, videos, and what to do in kind of the 1 to 3 minutes that you have if your car goes into the water.
Does he break the windows?
So I have put a link in the chat there. You can go and look at that.
Wonderful. Good. Okay.
And while I turned away, Arnold Schwarzenegger became a penguin.
Yeah, that's awesome.
Yeah.
You know what? It'll get canceled, but I'd like to propose an entire course on penguins. Because I think we can talk about anything and relate it to penguins.
I would do the same thing with ants.
Yeah.
Yeah. We should do UNV courses. UNIV.
Yeah.
For free.
For free.
Yeah.
Yeah. You know what? I may miss teaching so much that might be a thing.
We'll just do it on the street. It'll be, you can come to our road and we'll be out there shouting things.
Okay. So biodiversity on a global scale in the context of climate change or the climate crisis. Remember this one? Okay. So where are we going to see the greatest changes in average temperature?
Stampity stamp.
Stampity stamp. We should just make this the final exam test. Okay. Yeah. The delta, right? The changes in average temperature, not the highest average temperature, but the changes. That's good.
I saw some of you put some stamps in. Oh my God, is that the time?
Yeah.
The latitudes.
Yeah.
If you're thinking about elevation.
Elevation, you're
perhaps.
right. Yeah. Yeah. Okay, super. Now, where are we going? I don't want to delete so I'm not going to clear it. Where are we going to see the greatest decrease in alpha diversity?
Yeah.
There we go. Yep. And Abby, good. Yep. Lindsay,
all across
good.
The equatorial.
Yeah. Sam, good. You can go all the way across, right? The greatest decrease in alpha diversity, right? Because even though the average won't increase in temperature won't be as great as it is in the poles, it will certainly put those species over their thresholds much faster. Okay.
And come back and take another course to learn why those thresholds are generally much smaller.
Much smaller, yeah.
Than Arctic or polar species.
That's right. I mean, Arctic and polar species, they experience daily ranges in temperatures that can be almost 80 degrees Celsius. Yeah. Whereas these guys are
8 is like, oh my God, that's stressful.
Yeah. Okay, cool. So you got that right. Good. Now, next. We don't need to do that. Here. So we take a look at the predicted regional temperatures. So you totally nailed that. We see an increase in the polar regions, and no one's really looking at Antarctica, but the peninsula here is also considered to be one of the fastest warming places on the planet. And it's really a question about beta diversity. Right? So we're going to see a decrease in alpha diversity along the equator. Where are we going to see an increase in alpha diversity on the planet? Alpha, an increase in alpha diversity in the context of the climate crisis. Where? Yeah. Exactly. So we're seeing that right now, right? An increase in invasive species. My master's student, who's actually from Iqaluit is looking exactly at this and starting to see sawflies and things like this that just would not naturally or over a long period of time in the past historically been there. And so we're seeing more and more species coming into this region. It's an increase in alpha diversity. And one of the things that we want to kind of just challenge you with is to question whether or not high biodiversity as expressed by species richness is always a good thing. Because I think we can recognize why an increase in biodiversity or alpha diversity in the Arctic is probably not necessarily a good thing, right? Cool.
So some of you had asked as we kind of walk towards the door about these recordings. They're all available on your course link for sure. They're all there because they're on YouTube, and there is a playlist from our channel that you can go if you wanted and watch all of the hours that we've spent together from start to finish. Shuffle it if you want.
23 hours.
So take a look. That's on the left-hand side. That is a link when you get the PDF later on, and then the right-hand side is a link to the music of 190 upbeat tunes.
They'll use it as a sleep app.
Yeah.
Okay. And with that, thank you.
Yeah.
So much. It's been.
You've done great.
Yeah. Such a pleasure to spend this time with you. We appreciate your enthusiasm, your kindness. Please stay healthy and safe. Please wear a mask. And please get in touch.
Dr. Jacobs, I love teaching this course with you.
Yeah.
I appreciate you.
It's been really fun. It's kind of the end of an era.
Yeah.
Oh, well. We'll figure it out.
Yeah, you.
It'll be okay. Yay, you. Bye.
Be kind.
Thank you, thank you.
I'm going to keep
Bye.
writing.
Oh, yeah. See, but folks are still writing in the chat and stuff, so, whatever.
I know, but my hands hurt. It's got to follow my body.
I'm just going to, just...
No, don't call me on this.
Totally. I'm not going to go
Our children
away.
won't eat.
Go.
That's the consequence.
Okay.
Ugh.
Oh. Bye. I'm going to stick around for student hours, so... Yeah.
I'm going to go feed children.
Go feed our children.
I like the idea. Some of you talked about the fact that you had you learned best by being shouted at on a street corner, and I'm not sure what kind of learning style that is, but I love it.
If you see us downtown Guelph. Amazing. Okay. Take care, everyone. And I'm here. Let me just put this on stop recording.